When Facebook acquired Instagram, one of the first systems Instagram plugged into was Facebook's internal spam and fraud prevention system. Pete Hunt was the first Facebook engineer to join the Instagram team, and he witnessed the positive impact that this spam and fraud prevention system had on Instagram. When Pete joined Instagram, the big problems at Instagram were around these fake accounts, the harassment, and the large volumes of spammy comments. And a lot of this got cleaned up. So Pete decided to start a company to build products that would allow this type of spam and fraud prevention as a service. Smyte is Pete's company. It provides protection against bad actors on the internet. Complex marketplaces like Tilt, Meetup, and TaskRabbit all plug into Smyte to filter their transactions for suspicious behavior. In this episode, we talk about how this type of behavior manifests and the types of patterns that Smyte can detect once it is plugged into a data feed from one of these companies. And the event-driven software architecture that the team at Smyte has built is reminiscent of the episode on event sourcing that we did with Neha Narkhede not long ago. Event-driven programming is increasing in popularity, and at all areas of the stack, which Pete and I get into, it's present at the level of React in JavaScript frameworks, and it's present at the lower level, like with Kafka event sourcing. And like I said, Pete and I get into this in detail, so I hope you enjoy this episode, Fraud Prevention with Pete Hunt. Indeed Prime flips the typical model of job search and makes it easy to apply to multiple jobs and get multiple offers. Indeed Prime simplifies your job search and helps you land that ideal software engineering position from companies like Facebook or Uber or Dropbox. Candidates get immediate exposure to top companies with just one simple application to Indeed Prime. And the companies on Prime's exclusive platform message the candidates with salary and equity up front. Indeed Prime is 100% free for candidates. There are no strings attached. Sign up now and help support Software Engineering Daily by going to Indeed.com/SEDaily. That's Indeed.com/SEDaily if you're looking for a job and want a simpler job search experience. You can also put money in your pocket by referring your friends and colleagues. Refer a software engineer to the platform and get $200 when they get contacted by a company, and $2,000 when they accept a job through Prime. You can learn more about this at Indeed.com/prime/referral. That's Indeed.com/prime/referral for the Indeed referral program. Thanks to Indeed for being a continued sponsor of Software Engineering Daily. If I ever leave the podcasting world and need to find a job once again, Indeed Prime will be my first stop. Pete Hunt is the co-founder of Smyte. Pete, welcome to Software Engineering Daily.
Thanks, Jeff.
Today we're going to talk about fraud, and fraud is all over the internet in various forms. At Smyte, you are working on some anti-fraud technology, anti-bad actor technology. What are some of the canonical types of fraud and bad actors that exist online?
Oh man, that's a great question. The first thing that you want to do is kind of think about how you define it. And the way that we think about fraud and abuse and bad behavior in general is just people who are authenticating your application, but they're using it in a way that it wasn't intended. So a couple examples of this would be credit card chargebacks. So somebody purchases a product on your service, they receive the product because you mail it to them, and then a couple of weeks later, the merchant gets a chargeback, and the credit card company basically takes their money away. So you've received the product for free. Another type of fraud would be account takeover. So this is, you've created an account, but somebody figures out your password somehow, whether they get it from a data breach or they phish you. There's other types of, bad behavior that we look at, it's not just limited to fraud. This includes things like spammy messaging on social networks, creating a bunch of sock puppet accounts, sending people messages that they don't want to receive. This includes things like online harassment and all sorts of bad stuff that you see on social networks. So there's a wide variety of it, and this doesn't even get into the world of ad click fraud, which I know that you've been doing a couple podcasts on recently.
Absolutely. And I want to talk about some of those individual types of fraud and bad actors, but let's start at a little bit of a higher level for a little while longer. So when did you start thinking about fraud? When did you start considering making a business that would try to combat fraud or bad actors?
So I was at Facebook for a number of years before starting Smyte. I started as an engineer building the video and photos product over at Facebook. Then later I went over to Instagram and built out, I was the first engineer to go from Facebook to Instagram. And one thing that I noticed was, when Facebook made that acquisition, the first thing that Facebook did was plugged Instagram into Facebook's what they call site integrity system. And this is the system at Facebook that protects all the users from all sorts of bad behavior. Like a lot of the stuff that I mentioned earlier, this system helps protect Facebook users from that stuff. And, if you take a look at what Facebook's value proposition is, a lot of it is, hey, this is a really safe place for you to, put your information, and you don't have to worry, theoretically, you don't have to worry about a lot of spam and unwanted messages coming in. I thought it was really interesting that, literally the first project that they kicked off was integrating Instagram with this, with a site integrity system. And I wondered why, Instagram didn't have a solution for this before. I had seen how valuable, or how much kind of bad stuff there is on the internet before. So I started asking around and looking at the market and realized that there was nobody really solving this problem in the way that the big companies like, Facebook, Google, LinkedIn, even Yahoo were solving it.
And across these different domains like Facebook, Airbnb, Yahoo, PayPal, do the bad actors look the same? Is there some kind of domain agnostic characteristic set that is true of bad actors in all of these different places?
Yeah, that's a great question. So obviously it does vary. One of the clear delineations is, is this a real person or is this some sort of automated system? So a good example is somebody sending harassing messages actually looks a lot different than somebody who is sending a bunch of automated spam or, doing a bunch of credit card testing where they have a stack of stolen credit cards and they run them all and they try to figure out which ones work and which ones don't. But the one thing that we did notice was that all of these systems are built on the same set of fundamental primitives. So even though the patterns of behavior might be pretty different, you still use the same fundamental building blocks to identify them. You just change the parameters and the policies that you apply.
In terms of dealing with fraud, these systems, these businesses like Facebook, they often use manual review processes in conjunction with their automated process, like a typical, and this gets into the supervised learning process, but the way it frequently works is you've got this automated system, and if somebody gets flagged in the automated process, maybe it gets kicked to a manual review process. What are some of the patterns that companies are using to integrate the manual review process with the automated process?
That's that's kind of the question, right? Is if you kind of zoom out and think about it pretty simplistically, you can start to bucket kind of behavior into obviously bad, we can automatically take action on that. Obviously good, we don't have to do anything about it. And then there's this gray area of stuff that we want to send to humans for manual review. And, the real question is, how much does this bad behavior cost you versus how much does it cost for you to perform the manual review? And you need to decide kind of what that trade-off is. And it does vary a lot between different businesses. Like I'll give you an example. You don't want to review every single spammy message or borderline spammy message on a social network just because there's way too many of them, and each one probably costs you not that much in terms of brand damage or financial damage. Whereas if somebody is making a multi-$1,000 payment, you'll probably want to flag that if there's any sort of risky characteristics there. So it's certainly a trade-off. The way the workflow generally works is you have some sort of automatic classification system like Smyte, looking at the behavior in real time. It puts it into either that one of those three buckets, the obviously bad, obviously good, or needs manual review. And if it needs manual review, it will go to some sort of queue that a team will start to go through, and then they will make a judgment on that, whether we should have allowed it or should have blocked it. And then we want to get those markings actually back into that classification system to determine, hey, was this a false positive or a false negative?
So some specific areas we can talk about are types of fraud that occur in marketplaces. We could talk about social media fraud. We could talk about ad fraud. We should get into these, but I guess we should talk a little bit about Smyte in terms of the product and how companies integrate with it. So let's say I have some product like a payment system or social network, whichever example you think would be most fitting. How would I hook into an anti-fraud system like Smyte and begin to detect bad actors?
So the way that kind of other security and fraud companies have worked in the past is they've used kind of signature-based detection, where you drop maybe a script tag on your web page. It does something, creates some sort of unique fingerprint, and then you use that fingerprint. Then you attach basically a risk score to that fingerprint. So, maybe we know that this IP address is a proxy that's associated with some malicious behavior in the past. And when we combine that with maybe the billing address, we can determine whether that's fraudulent or not. We work a little bit differently. We really look at, and this is what I was talking about when I mentioned that kind of the larger companies like Facebook, Google, LinkedIn, do it a little bit differently. They look at the user's behavior over time. So the first thing you need to do is get an event stream into Smyte or whatever classification system you're using. So these events are pretty similar to what you would send to kind of your marketing analytics system, but it might have some additional data in there. So this would be, this user logged in. Here are the HTTP headers that were part of the request. Here's the username that they used. This user browsed around this page. They sent this message. Here's the content of the message. Here's the recipient ID. And so we need to get that event stream somehow. So we'll get it from either a REST API that we offer, where they just send new line separated JSON messages to us. Or we can pull it out of an existing data warehouse or analytics system. So if you're using Segment, you just flip a switch in the Segment console and we start getting those events. If you're using Redshift, depending on what data you have in Redshift, a lot of times we can just pull those events right out of Redshift, even though they'll be a little bit delayed. So once we have the events inside of Smyte, we can start to do a high-level analysis. And we can kind of turn on some generic rules and models that we have to identify common types of fraud, like sock puppet accounts. So if one IP address, for example, like this is the easiest signal in the world, but like one IP address creating thousands of accounts a minute, we'll detect that automatically. Or credit card testing, that's another really common, easy to spot type of fraud. But where it starts to get more interesting is when you take a look at your application and the unique ways that it can be abused. There's a bunch of different ways that you can abuse a crowdfunding platform. And it's a lot easier to abuse a crowdfunding platform than it is maybe an e-commerce application. And so once you start to take a look at the specific application, you start to want to write custom rules, train custom machine learning models. And that's where we start to really get into the specifics of the different types of fraud. And
so what is the relationship? Like, how do you develop a relationship with the company? So Tilt, for example, this crowdfunding platform that you have worked with and helped to prevent fraud, the mechanisms that can be used to defraud a crowdfunding platform, I could imagine very sophisticated systems. So you get hooked into the event stream of Tilt, so you can build up a data model of what's going on across the Tilt user base. and then, so what happens next? How do you train your system to recognize bad actors? Do you have to spend some time letting the system bake and build up its own model for what is bad actors? Do you have to feed it some labeled data in parallel? Or maybe you could just give me a picture of what you did with Tilt as an example.
Oh, yeah. So you touched on this right at the beginning, which is the best systems are a combination of humans and people, or of humans and computers working together, right? You were talking a little bit about that manual review process for the gray area stuff. So the way that we look at it is, machine learning is great and it catches a lot of stuff, but it's relying exclusively on machine learning has kind of a couple of problems. The first problem is that you do require labeled data. And for a lot of fraud cases, you don't actually have a true positive or true negative signal. You just kind of have these kind of events that come in that may indicate that this was a bad action or a good action. Another thing is that in the case of credit card fraud, the chargeback may come 6 or 8 weeks later, at which point, if they did a big fraud campaign, you would miss all of that stuff until 6 weeks later when it's too late. So the way that we kind of think about it is, we'll leverage all this machine learning stuff and rules-based approach and unsupervised kind of clustering, but we also want to give our customers the capability to create their own rules and train their own machine learning models and basically take all of the intuitive knowledge that a customer has about their system and inject it into Smyte. So the way that this works is we get the event stream from them somehow. Then we turn on our generic stuff that catches the obvious patterns that kind of repeat themselves across the internet. And then we sit down with a customer and we say, hey, what are the things that you're worried about? Do you have any sort of patterns that you've seen in the past that indicate, abuse specific to your application? So a lot of times we'll sit down with one of these fraud operations people or PM, and they'll say, oh yeah, we noticed that when people create crowdfunding campaigns for vacations, the fraud rate tends to be a lot higher. And that's not the type of thing that a machine learning model would pick up on without a ton of historical and labeled data. But a human who's worked on the system understands it. So during that onboarding phase, we'll write some rules for them or maybe train a model for them. And as they start to kind of get better and better, once Smyte is delivering them really positive ROI, our customers start to kind of take over and write their own rules or train their own models. And they give us a call if there's something they can't figure out.
And they're typically doing stuff where, well, I guess they could do whatever they want. They could either respond to a transaction being labeled potentially malicious by just canceling the transaction, or they could do something where they kick it to a manual review process. Exactly.
And, we really simplified the workflow here, and we talked, or the different states that a transaction could be in as either good, bad, or in review. In reality, we actually want to create a lot more states for something. So a really good example is if you're a social network, you really don't want to kick users off of your system. It's really, false positive in these cases is just really frustrating. If somebody is storing all of their photos with you and then you kick them off, they're going to be really bummed. So maybe, if they're slightly risky, but not so risky that we want to automatically take them out of the system, maybe we show a CAPTCHA, or maybe we require SMS verification. Now, answering a CAPTCHA and doing SMS verification is something we could do on every single user, but that'll reduce our customers' conversion rate. So there's also kind of this tension between how much fraud do you want on your system versus, how quickly do you want to grow? That a lot of companies face. And we want to actually make that less of a trade-off by only deploying those countermeasures for the risky accounts.
The Insight Data Engineering program helps software engineers level up their careers. Data engineering is at the cutting edge of how we build software, and it involves some of the most interesting open source and distributed technologies, such as Apache Spark, Kafka, and NoSQL databases. Insight Data Engineering is free because they partner with top companies like Facebook, Uber, Capital One, and Slack. You can learn about data engineering at Insight Data Engineering. And if you go to insightdataengineering.com/sedaily, you can apply. Listeners of this show will be advanced straight to the coding challenge of the application process. If you get accepted, you get to learn how to build useful products in a self-directed program. There are workspaces in New York and Palo Alto that you can utilize during the short 7-week data engineering training process, and you have access to free cloud computing resources and a network of over 600 data engineers and data scientists from over 100 companies. Insight provides this support until you find a great data engineering position at a top company. Apply now at insightdataengineering.com/sedaily. Skip straight to the coding challenge. This is a special offer for Software Engineering Daily listeners. Thanks to Insight Data Engineering. And if you want to level up your career, if you want to learn some new skills and change what you are working on in your work environment, and perhaps get a job upgrade if you're looking for a different type of job, or if you're between academia and your career path and you want to build a little more skill before you jump on that career path, learn about data engineering at Insight Data Engineering. Go to insightdataengineering.com/sedaily to apply and skip straight to that coding challenge. And thanks again to Insight Data Engineering for being a new sponsor of Software Engineering Daily. You can also check out the interview I did with Insight Data Engineering several months ago on Software Engineering Daily. Let's get back to this episode. These marketplace businesses, I want to talk about these some. They're often making this trade-off in terms of they'll raise a ton of money, and one of the reasons these marketplaces raise so much money is because of the volume of fraud that they have to deal with, and especially these newer types of businesses like Uber and Airbnb have really sophisticated fraudsters that pull all kinds of stuff that's hard to see coming because they're so new. And then, of course, you've got PayPal, which is a payments company, and this is just like there's all kinds of fraud that can occur over payments. Certainly, sophisticated fraud can occur in a marketplace like Amazon. Can you talk more about how you would build custom rules and what types of rules you would put in place for these different domains and how that would work with Smyte?
Oh, yeah. I mean, there's just so many ways to exploit these marketplaces as well as other types of products like that. Anytime that there's an untrusted buyer and an untrusted seller, there's just so many different things that you can do. So, in terms of the different signals that we would want to look at, one interesting one, and I'm hoping I'm not giving too much away to the fraudsters listening to the podcast, and I can talk about the different kind of streaming data techniques that we use to actually implement this stuff. But looking at the diversity of and distribution of email domains, maybe grouped by the merchant or grouped by the person selling the item on the marketplace. So if you create some item, like let's say that you have a stack of stolen credit cards and you want to make a bunch of money, you'll list a fake item on a marketplace and then you'll pay yourself for this item, get the money and then run away. So a lot of times if you want to pay yourself a lot, you would create a bunch of fake accounts on the buyer side. It's a lot easier to create fake accounts with non-Gmail domains or Outlook.com domains rather than various other email providers, or it's a lot harder to get a .edu domain, for example. So if we just look at the diversity and distribution of those domains, that might be one signal that we could use to identify the risky items on the marketplace.
Now, is it harder to police fraudulent tactics that are in like that take more than two people? Because maybe the two-person transactions that are fraudulent are easier to police, and is it harder to police ones that have like more sophisticated like 3-person transactions?
Could you give like an example of what you mean?
I actually can't think of one. I'm not sure. I guess most of these are just two-sided marketplaces.
Yeah, I mean, there might be like maybe like a contract work site where there's a project owner and a contractor and a customer. Yeah, I mean, you just need a flexible enough data model to represent it in your system. And that's actually like a lot of the challenge is, you've got all these different applications. What sort of data model fits all of these applications? And the answer is you can represent a lot of different things with directed graphs.
Okay, so is that how you're modeling this data behind the scenes? Is it because it's coming in as event streams? And yeah, we should talk about the streaming some, by the way. So I guess it's coming in as event streams from the company, and actually the reason we started this, we did decide to do this podcast episode is because we were talking over Twitter about how the back-end models that are popular today look somewhat like the things that are happening on the front end. You have this event-based architecture where events come in a stream, and then you pull events off of this queue and update your data model. And that sounds a lot like what Smyte looks like. So maybe you could describe. So you've got for a company like Tilt, this crowdfunding platform, you've got this pipeline of events that are coming in. What happens is you pull those events off of the stream.
Yeah. So let's talk about exactly how the classifiers work. So it's easiest to think of them in terms of rules, and rules can have machine learning models as inputs, but we want to make the final decision as a rule so we can communicate to the user a little bit of information as to why the decision was made. But the way that we train ML models and the way that we classify with rules is for the purposes of this discussion, not that interesting. So the first thing that you need to realize is that a really powerful rules or ML system like Smyte is stateful. So it's not just like if country equals Russia, then block the payment. Actually, like a lot of companies do that and they lose a lot of revenue because of it. So rules need to classify things as well as do various mutable operations. So this would include decrementing a rate limiter. So we say maybe this user is allowed to make 10 payments a day, and when they go below that, we want to kind of not allow that payment. So the rule has to say, hey, do we have enough quota remaining? And if we do, allow the payment and then decrement that bucket. We want to count things too. We want to say how many unique or how many failed payments did this item in this marketplace get in the last hour, and compare that to the last day. And if it's increasing really quickly, maybe we want to slow down or stop paying out that item on the marketplace until we can investigate. A third type of stateful analysis that or state that we keep around is it's an algorithm called sliding hyperlog log, but it's basically a time-windowed set cardinality. So how many unique user IDs have been seen on this IP? How many, the email domain diversity thing, how many unique email domains have we seen associated with this item on the marketplace? And then we also have a graph representation. So maybe we'll add some edges between different entities in the graph and propagate reputation between them. So that's kind of like the types of state updates that we want to do. And we also want to emit labels from these rules. And we want to say, hey, this particular entity, so maybe it's a user or a payment or a comment, has the label bad user or spammy comment or needs review. And the way that we implement all of this stuff on top of Kafka, we're big fans of event sourcing. So the event comes off the wire from Tilt or whoever it is. They send it to us generally with a REST API. It goes, that endpoint, all it does is it writes it to Kafka, and we call it a day. On the other side of Kafka, we have our kind of classifier that comes in, runs those rules, and does that classification. And the way that it does it is, if it needs to know the value of a rate limit, or if it needs to fetch some edges from that graph database, or do one of these set cardinalities, it goes and it talks to some internal stateful service that we have. It says, hey, I've got this key. What's the current count, or what's the 90th percentile or whatever, and it gets that back, does the classification, writes the classification result to Kafka, and we have another tailor that listens to this classification results and then delivers the webhooks back over to the customer. And we have, for all of the other stuff, like adding an edge to that graph database or bumping a counter or decrementing rate limit, a lot of times those mutations are also events that are put into Kafka, and then those databases tail that and process all of the mutations through Kafka. Not sure if that answers your question.
No, it certainly does. That's very interesting. So this event sourcing stuff, can you describe why that's useful? I mean, we had this episode recently about Kafka event sourcing, which I think you listened to with Neha, and this was all about why you want to model your backend like this. Like, why would you want to have this stream of events that is decoupled from the actual data model? Maybe you could just talk a bit about that, for people who didn't hear that episode or they heard it and they're looking for more clarification on why event sourcing is useful. Maybe you could just give more color on why that's useful.
Yeah, that'd be great. Martin Kleppman, who is associated with the Kafka project somehow, I'm not exactly sure. I know he worked at LinkedIn. He gave this great talk at Strange Loop a couple years ago that I saw called Turning the Database Inside Out. And that talk just like totally changed my professional life. I thought it was really, really great, super interesting. And he basically talks about all the uses or all of the use cases for relational databases and caching layers and search indexes, and how you can implement them effectively with event sourcing. So the key idea with event sourcing is, rather than treat your relational database as kind of the source of truth and the really, really important data store, you treat the event log as the source of truth and the really, really important database. And for us, that event log is implemented as Kafka. A lot of people are using Kafka for this. And the idea here is that if you have theoretically, if you kept every event on your application from the beginning of time, you could spin up a new materialized view of that log, which is basically, you can think of it as like a reduce operation on all of the events from the beginning of time, and then it creates the search result that you want. So if you take it from kind of like a first principles approach, if I wanted to search for all of the comments that you made on Facebook, and I was using an event sourcing approach, I could replay every single event from the beginning of time and filter the ones that had username equals Jeff, and then return those results, right? Like that's theoretically possible, but anybody who's thought about scale realizes that that's going to be way too slow because there's just going to be so many events in that stream. So what you really want to do is create some sort of index or materialized view of that entire event stream that only, first of all, keeps the latest version of the comment. So if you made edits to the comment, it squishes them all down into kind of one row in the database, and also lets you look up comments by ID. So you would spin up a new Kafka tailor that then indexes all of those comment events into Solr or Elasticsearch or MySQL or whatever data store is appropriate. And then if you realize that you need to query your data in a different way, maybe you want to look up all of the comments that somebody was mentioned in, for example. You can actually just bring up that tailor on the same kind of event log and then replay all of the events from the beginning of time or from a period of time. If maybe you want to bring up this new service and only offer it for the comments made in the last year, you can basically just start it at some place in that event log, and it will eventually converge and come up. And it's really, really easy for you to bring up new services. And if for whatever reason you lose that service, it goes down, and you have to restore from a snapshot, it's as simple as restoring from the snapshot and starting from that log where you last left off. So it makes ops really easy.
Definitely. So are there consistency concerns from your standpoint at Smyte? Because if you have this event-based architecture where Kafka is the source of truth, you have these different data models that are subscribing to changes in Kafka, you could potentially have consistency issues with different data sources that are pulling from Kafka. Maybe that's not as much of a concern with Smyte, or is it?
So yeah, I mean, this is the kind of distributed transaction problem. So a little bit about how Kafka works for people that aren't familiar with it. You have this notion of a Kafka topic. It's sort of analogous to like a table in a SQL database where you're logging different events into a given topic. For us, we have a topic called raw actions, which is where we get all the raw data from our customers. And then we'll have a topic called counters, where we store all of the increments and decrements for counters. Another topic for all of those other stateful services, a topic for labels, which is all the classification results, etc. And each of those topics can be divided into one or more partitions. And a partition is just a shard. So when you send a message into Kafka, you can either pick a random partition, or you can pick a specific partition if you want to shard by a particular key. So if you really need like some degree of consistency at scale, you really need to do sharding at that point. And event sourcing lets you do that very easily, right? When you ingest the data, you pick the partition that corresponds to that shard, and then all of the data that you need for that kind of distributed transaction should live on only one shard. Now, if you can't pick one partition for all of the different ways that you want to query your data, for example, or you have a Kafka topic that goes back many years, and you weren't partitioning it correctly, you could start up another stream processor that tails the old Kafka topic, picks a new partition key, and then publishes it to a new topic. Does that make sense?
Yes, it does. So the other question I had about the architecture was like, when you were discussing on Twitter, like how the back-end patterns are looking similar to the front-end patterns. You were heavily involved with developing React at Facebook. What are the and you obviously mentioned that this strange loop talk, so that was probably influential for you. I don't know if it was influential in regard to React also, but what are the trends that are pushing us towards this this event sourcing based model, and how does it look on the front end? Because you've already explained how it looks on the back end in terms of Kafka. How does that translate to what people are doing on the front end with React?
Yeah, let me. So we already gave kind of a good overview of event sourcing, on the server side. On the client side, we're actually starting to see a lot of traction with this pattern too. There's a pattern that Facebook came out with that works really well with React. It's called Flux. The most popular JavaScript implementation of it is called Redux. And the idea here is that every sort of event that happens in your front end, the user clicks on this thing, they type in their name, they receive a request back from the server, goes into this centralized event queue, and then you have what Redux calls reducers and what Flux calls stores, basically listening to events on that queue and then reducing them down to some canonical piece of state that is then rendered by your React components. And this is actually exactly the same thing as event sourcing on the server, right? I mentioned we have this topic of events or actions that come in from the customer, and then we spin up a database that creates this materialized view of that event stream that's easy to query. It's the exact same thing on the client side. And
so instead of a materialized view, you have a React component.
Well, it's a materialized view that's passed to the React component.
Right. Oh, okay, sure.
If you think of like the event stream as the source of truth, then you can almost think of anything else in your application as just some sort of materialized view on top of that event stream. Like even the DOM structure that eventually gets displayed is a materialized view of that state, which was a materialized view of that event stream.
Continuous integration gives you faster, safer software delivery. With a continuous integration tool like Snap CI from ThoughtWorks, the members of your team can push changes independently of each other, and they can all see their new builds running against different phases of tests before those changes make their way into production. The fastest moving companies that I've talked to on Software Engineering Daily are all using continuous integration. SnapCI from ThoughtWorks is available to anyone. And if you go to snap.ci/software engineering daily, you can check it out for yourself and support Software Engineering Daily. With just a few clicks, I had my own continuous integration set up for some projects that were just sitting in my GitHub account without continuous integration. I got continuous integration up quite easily using SnapCI. If you want to be that hero at your company that starts moving your organization towards deploying often, more confidently, towards that DevOps dream, start working with SnapCI at snap.ci/software engineering daily. Your coworkers will see you working with SnapCI, and they will fall in love with it themselves. Oftentimes, it takes somebody at a bigger company to go out on their own and say, okay, I'm going to roll out CI even though nobody else at the company is using it, and maybe that hero at the company is going to be you. So check out snap.ci/software engineering daily, and thanks to ThoughtWorks for being a continued sponsor of Software Engineering Daily. It really means a lot. I want to talk about advertising fraud because we were discussing it a bit before the show. I know that's a bit of a distance from the streaming architecture conversation we were just having, but maybe we can get back after we talked about ad fraud for a bit. We can talk about how Smyte might be used to combat ad fraud. But as you've been listening to these shows about ad fraud, you know that I've been interested in this topic. So what's interesting to me about ad fraud is not necessarily like the size of the fraud, because there's probably bigger fraud schemes taking place in marketplace businesses and payment businesses, but ad fraud doesn't get talked about very much. And my suspicion is that the reason that people don't talk about it is because if you question the legitimacy of the advertising ecosystem, if you question its legitimacy at a large scale, then that requires questioning the integrity of Google. It requires questioning the integrity of Facebook, potentially. And I mean, I love Google and Facebook. I love these products. So for me, this is almost like a religious person questioning God. But, you came from Facebook, so I'm sure you have adoration for the company as well. But now you're spending time in the fraud space. Maybe you're getting an even more bleak view of human nature than you had before. What do you think of online advertising? How much fraud is there?
Well, that's interesting. There are entire companies that are dedicated solely to ad fraud.
To committing it or preventing it?
Well, I was going to say preventing it. I'm not the world's leading expert on this, but I do know a bit about advertising because I did work on it while I was at Instagram. So the first thing that I think we need to think about here is that there's two different types of advertising online. There's direct response and there's brand advertising. Direct response is kind of, you see a message. This is like the classic kind of Google AdWords model. You're searching for something. You're searching for a new car. Mitsubishi has a link that pops up that says, hey, buy this car from your local Mitsubishi dealer. You click it, you buy the car. There's some value to that click because it eventually, hopefully, will convert in a sale. Then there's brand advertising, which is you're watching TV. You might not even be in the market for a car, and you see a commercial for the new Mitsubishi, and you're like, oh yeah, that does look like a cool car. And then when you later go on to make that purchase, you're kind of thinking of Mitsubishi when you go to make that purchase. So those are two very different types of advertising with different metrics. With direct response, the way that it's been historically, like ads have been priced in terms of something called CPM, which is basically you pay some fraction of a cent for every impression of that ad, and that was for both direct response and brand advertising online. Google was interesting when they came out with AdWords because they priced it with something called CPC, which is cost per click. And the thinking here was, hey, the whole point of direct response advertising is to get a response. So every time somebody clicks on that, we're going to indicate, we're going to use that as our metric for hey, this person is engaged and is responding to this ad, and it makes sense for the advertiser to pay us there. So there's those two systems are really easy to game with fraud, right? Because you can just create bots that view a bunch of ads, and you create bots that click on a bunch of ads, and that will affect the price of those clicks or those impressions without actually getting the advertiser any new customers. There's been a shift kind of over the past couple of years towards what's called CPA advertising, where you actually measure the attribution from the impression all the way to the final sale. And you kind of get paid out based on whether that person ends up actually buying a car or not. And this is all in direct response advertising, right? So when we talk a lot about ad fraud and direct response, I'm starting to think that, for the companies that are measuring on a CPA basis, that is actually baked into the price of the ad. Does that make sense?
Well, so you would know it's baked in basically because those campaigns are measured against the sale at the end?
Yeah, these advertisers are always measuring the ROI, and they're able to measure that attribution, or they're able to keep track of that attribution. So as there's more fraud in the ad space, the value of each individual impression is going down. So the price does kind of equalize.
So what percentage of so the advertising is moving significantly towards CPA? Like are most campaigns these days CPA, or are they still mostly brand campaigns, like CPM campaigns?
I'm not an advertising expert, so
fair enough.
We're starting to hit the limits of what I know.
Okay, fair enough. But do you think it's hard for people to talk about this problem? Because it seems like there's not much incentive for many people to talk about it. I mean, that's my sense in trying to get people from the bigger companies to discuss it. It seems like the only interest in preventing ad fraud is kind of coming from perhaps like the big brands like Procter & Gamble or Ford.
Yeah, so I think that basically these advertisers are measuring the performance of their campaigns all the time. And if there's not positive ROI, they'll negotiate down like a lower price, or they'll move to a different platform. So I think that there's I think when publishers are reporting like, hey, we have this many eyeballs looking at our service, that's when you start to get into this world where ad fraud is a huge deal. So if you're looking at all these different advertising options, where do you spend your money and where do you spend your time trying out the new platform? I think it's hard to trust a lot of these numbers because, as people have said on many previous shows, there's so many bots out there, so much low quality traffic. And when you think about the incentives around brand advertising, where there's no action at the end that ties it back to the original impression, that's where the ad fraud, I think, gets really scary.
How do companies, and this is a question about all companies, not just advertising companies, but how do companies quantify how much fraud is going on in their platform?
Yeah, that's always the question, because just due to the nature of fraud, you very rarely know your true false positive or true false negative signal. So a lot of times you rely on proxy metrics, just kind of going back to more of our core use cases. Maybe on a social network, if an account hasn't been reported in 6 weeks or hasn't had any content reported by a user in 6 weeks, maybe we'll treat them as a good account. And maybe we'll train models looking at them as kind of the source of truth for good behavior. And then if there's significant deviations from that, we'll treat that as a bad account.
Okay, so thinking about the ad fraud space, how are you modeling solutions in Smyte to deal with that?
With ad fraud? Well, we just try to look at user behavior. And one of the labels that we apply is possible bot. And based on a number of different heuristics about the actual behavior that they're performing in the application, we can generally do a pretty good job of kicking out the bots. So it's basically you have your monthly active user count that you think you have, and then we kind of pull some users out of there that we think are fake, or duplicate accounts. And then we say, hey, this is actually your real monthly active user count. And then we can remove all of the impressions from those kind of known botting users. And the way a lot of companies are doing it right now is they're maintaining like shared blacklists or whitelists, and they're, maybe looking at some properties of the device, like do they move their mouse or not, that type of thing. But as it's this kind of like war where we're always kind of trying to one up each other, us and the fraudsters. And so as they start to get more advanced, you're going to want to look at, okay, are they using the service in a way that normal humans do? And in order to do that, you need that kind of rich event stream.
So could you talk about maybe another example of, Meetup. Meetup is a great example. Like this is a case study that exists on your site. And Meetup, I think, is interesting because it's a social network. It's kind of a marketplace. And the types of scams that occur there are like, I saw it listed on your site, like dating scams, fake profiles, abusive messages. Can you give an example of how Smyte would solve these types of problems?
Oh yeah, there's so many interesting types of attacks that you see. So let's talk about the one that's listed on our website. These kind of romance scams. So basically, what happens is you need to find a willing victim, and who you think is likely to fall for this. And then you start an online relationship with them. And so if you think about the types of people that would start online relationships, you try to identify them and you try to specifically target them, just like a marketer would target, like a high value or high likelihood lead. And you start sending them messages, you create an account that looks legitimate. You start this online relationship with them, you do it for a couple weeks, and you say, hey, I'm stuck in an airport in this foreign country. Could you wire me some money so I can get home? They do it because you're their online relationship, and then they make out with the money. Now, in order to create all these accounts and actually be like a convincing online relationship, you actually have to be like a real person and invest a lot of time into cultivating these relationships. So it's pretty expensive. And in order to save time, a lot of times they'll do it at scale. And when you start to do it at scale, even if you have a great set of really clean IPs to do it from, and you clear all of your cookies and you have a sufficient browser and email diversity, there's still going to be unique patterns that give you away. There's going to be certain trigrams maybe that are associated with the types of messages that you send to these people. And so it's all about taking a lot of these kind of signals that may be low quality signals, but aggregate enough of them together and you can get a strong signal indicating, hey, this looks like a romance scam. So maybe they're using this unique phrase that is associated with it, plus they've contacted N people in the last day and only Y% of the people ever respond. And so when we combine those signals together, each one individually wouldn't be good enough, but all together, we can kick them off the service.
Right. Now, so when a company adopts Smyte, do they have to, so how much work is there? Do they assign like an engineer or a team to keeping the model of the fraud up to date? Or how do companies typically handle this? Do they typically have entire teams dedicated to fraud? Or maybe you could explain like how you are seeing people adopt Smyte in terms of who is responsible for working with the tool at their company.
Sure. So we like to use the phrase trust and safety rather than fraud, even though a lot of what we solve is fraud. And the reason for that is there's a million fraud companies that try to protect their customers' bottom line. And the difference with trust and safety is, sure, we try to protect our customers' bottom line, but more importantly, we try to protect our customers' users. So that romance scam, for example, does it cost Meetup money? Well, it probably would cost them a little bit of brand damage, but it's more about protecting their end users. And so at all of our companies or at all of our customers, there's some sort of trust and safety team that is tasked with protecting the user base. And they've always got some sort of metric. A lot of times the metric is proactive versus reactive responses. So if you report, if you write into the company and you say, hey, I got scammed on your service, that is reactive, and we want to minimize those and instead focus on proactive, which is, hey, we took down that account before anybody wrote in and said that they were being scammed.
Okay. Well, so as we begin to wrap up, can you talk about what's in the future for Smyte?
Yeah, so we're actually pushing out our brand new developer platform. So Smyte's got this really cool feature right now where we have this Git repo, and you can write your custom rules in JavaScript and Git push that repo, and then they roll out immediately. And a lot of times, if you have your own rules engine in-house, you have to wait for your infrastructure team to deploy the new rules. What we're doing now is we actually have a pretty cool domain-specific language that looks a lot like SQL, that makes it easier for more analyst-type people rather than engineers to write these rules and push them to production. And we're also introducing support for pushing custom TensorFlow models to Smyte as well.
Why would that be useful? So why would I want to push a custom TensorFlow model to Smyte?
Well, the choice of TensorFlow versus scikit-learn, which is the other one that we're using, does factor in. Generally, like we introduced TensorFlow for image analysis primarily. But the reason why you would want to push a custom machine learning model is you will see different patterns of behavior depending on what service you're on. So for one of our customers, which is a large social network that like a lot of high school kids use, and it's mobile only. They tend to use like a lot of emojis. And what we've noticed is that there's certain spam behavior that looks pretty legitimate, but we basically trained a custom classifier, or the customer trained a custom classifier on just the emojis in a message, and we were able to actually catch a lot of the spam on that service. And it's funny, we actually rolled that out maybe 2 months ago, and South Park did a spoof on internet trolling and called it emoji analysis, and we had a good laugh about it because it's actually what we did.
Cool. All right. Well, Pete, that seems like a good place to wrap up. I want to thank you for coming on the show. It's been a real pleasure talking to you, and I hope to talk to you again soon.
Great. Thanks a lot, Jeff.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.